The fifth video is about the important characteristics of the periodic table. The number of elements on the periodic table are 118, and they were arranged according to the increasing order of their atomic number. This is the arrangement according to Moseley. So if you can see, there are 7 rows, and we know what the rows are, okay? Horizontally arranged elements are rows, and there are 7 rows. So this is row 1, then you have row 2, 3, 4, 5, 6 and 7. Remember, the lanthanide and the actinide series are part of these 6th and 7th row. Okay, so there are 7 rows, and these rows are called as periods, and they're actually numbered 1 to 7. So here actually you can write 1, 2, 3, 4, 5, 6 and 7. Likewise, there are 18 columns. So if you look at the columns, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. There are 18 vertical columns, and these vertical columns are called as groups. So henceforth, when I say groups, you must remember they are vertical from top to bottom, and when I am going to say the word periods, it means horizontal rows from left to right. The 2 rows below are the lanthanide and the actinide series. Now, based on the electronic configuration, okay, we know how we write the electronic configuration of an element. Based on the electronic configuration, this table is divided into 4 blocks. 4 blocks. Now, 1 minute. Okay, so you can see over here the numbers 1, 2, 3, 4, 5, 6 and 7 periods, and if you number them like this, you get them 18. Okay, the 4 blocks are the S block, P block, D block and the F block. Now let us see what we mean by them. Okay, the first two groups, they together constitute the S block. Okay, when electrons start filling in the shells, they actually first come into the S block. Then they fill up into the next block, which is called the P block, and the P block is over here. Okay, so from group 13 to group 18. So this first group and the second group, these two groups are the S block. 13 to 18, all these groups over here, this whole box is the P block. From 3 to 12, okay, this little bit over here is the D block, and the one at the bottom, these 2 rows at the bottom, is called as the F block. So once again, I'll just say the group 1 and group 2 together constitute or make up the S block. P block is from group number 13 to 18, this little box here. D block is over here from group number 3 to 12, and the F block is below. Now all the blocks, okay, the S block, P block, D block and F block contain elements, but the S block, D block and the F block, these 3 blocks, they contain only metals, all metals. The P block is the only block which has metals, non-metals and metalloid, all. Okay, so this is a unique characteristic of this P block. So you can see here all in this little purple color, these are all, okay, these are metals. The metalloids are over here in between. I won't say all this purple. Metals are over here on this side. The metalloids are along this zigzag line, and non-metals are on this side. Okay, we'll come back to the previous slide which shows them well. Okay, so here you got in pink, here you got aluminium, gallium, okay, indium and so on. All these little pink ones, they are all metals. Tin, lead, all metals. The brown ones here are metalloids. So you've got boron, silicon, germanium, antimony, arsenic, tellurium and polonium, which are the metalloids, and on this side over here are the non-metals. And right at the end you can see there are over here are all 0 group elements. That means these elements at the last group, they have completely filled outermost orbit Therefore, they don't need to give or take electrons, and therefore they are called zero group elements. They are right at the corner. They are all gases. Now, there are special names given for some of these groups. Group 1 elements are also called alkali metals. Alkali metal, because when they react with water, they form alkalis. That's why they are called alkali metals. Group 2 are called alkaline earth metals, because these are mostly found in the earth. Okay, magnesium, calcium, and all found in the earth. So alkaline earth metals. Again, they form alkalis when they react with water. Therefore, alkali metals and alkaline earth metals are group 1 and group 2 respectively. Group 13 over here, okay, to group 18, these are called as normal groups. Normal, because the way of filling of the electrons is normal, therefore normal groups. Group 18 are called as zero group elements, and group 17, just before these are called as halogens. So in halogens you've got fluorine, chlorine, bromine, iodine, and astatine. So you must remember this. Okay, group 18 zero group, group 17 halogens, group 1 alkali metals, and group 2 is alkaline earth metals. These elements that are present in groups from 3 to 12, these are called as transition metal elements. Transition metal elements. They're given this name because while the filling of electrons into the orbit happens, sometimes before filling the outermost orbit gets filled before the inner orbit sometimes. Therefore, they are called as transition elements, and these elements of the lanthanides and actinides are called inner transition because they are inside this. So these are the names of the various groups and all which you must remember.